Namaskar, welcome back to my YouTube channel Remote Sensing GISO. Hope all are doing well. So kindly join my dear students as soon as possible. Okay, after that class will be started. So those are present in the classes, please mention your name to mark your attendance. Okay, so those are present in the classes, please mention your name to mark your attendance. Hi viewer, hi my dear students, please mark your attendance. Namaskar, welcome back to my YouTube channel Remote Sensing GISO. Hope all are doing well. Okay, so kindly join as soon as possible. After that class will be started. Hello, hi viewer, kindly join as soon as possible. Those are present in the classes, please mention every. Good evening to everyone. Those are present in the classes, please mention your name. I cannot see who are. Good evening Sudeshna, kindly join as soon as. Good evening Ankit. My audio and video is clear to everyone. My audio and video is clear to everyone. Good evening Shravani, kindly join as soon as possible. Very good evening to everyone. So we have already covered 2 MCQ series in the basic of remote sensing and the GIS. So today continue the different type of question about the remote sensing. Okay, hope you enjoy the classes. Good evening Sakshi. Okay, now 8:34. I will take another 2 or 3 minutes to start the classes. After that class will be started. Okay, so Sudeshna, Ankit, Shravani, Sakshi, how's you go your preparation? Because all about know that in 11th February, second half geomatics engineering GATE exam will be conduct. All about know that, my dear students, all about know that the date is 11th February. Okay, 2023, second half from the 1:30 to 5:30 p.m. Okay, okay Sudeshna, okay Ankit, okay Sakshi, thank you for your confirmation. Okay, so very good evening to everyone. Any problem regarding the gate or any topic? Okay, kindly join as soon as possible. I will waited last 30 minutes for the classes. Okay, so please try to attend at 8:30 p.m. Those are sitting in the classes. Few students are very conscious. Okay, and they have connect at 8:30 p.m. but some of the students are not conscious about the classes, that's why they join late. Okay, अच्छा, प्रतनु माइती, गुड इवनिंग। प्रतनु, कहाँ से हो आप? व्हाट टू यू बिलोंग्स? Okay, so let's start the today classes about the new some MCQ series. Okay, just give me another 1 minute. So are you ready guys to attend the MCQ series? Are you ready everyone? If you ready, please hit the yes button. If you ready, please hit the yes button. Okay, Madan, good evening Madan. If you are ready, please hit the yes button. Okay, good evening Madan. Are you ready for the MCQ series? Please hit the yes button. Okay, yes sir, yes, ready sir. Okay, so ready? So this is the today first question. A Higgs boom or spotlight sensor, also known as along track scanner, across track scanner, both A and B, none of these. So this is your first question. Okay, a Higgs boom or spotlight sensor, also known as last 8 seconds. Okay, at first try to answer Shravani, then Madan. It is very important. Okay, so answer is B. Okay, okay, Shubhajit, Shravani, Madan, try to answer everyone. Okay, it is not too mandatory to answer. Okay, if you give the wrong answer, it will be better to understand. Okay, so a Higgs boom or spotlight sensor, also known as across track scanner. Okay, so in the remote sensing, when satellite have a sensor, the sensor mostly in two type. One is along track scanner, another is across track scanner. Okay, so Higgs boom, so across track scanner or the Higgs boom scanner. Okay, across tracks mean, so you can see here the satellite path is if it is A, sorry, if it is A and B, this is the satellite path. Okay, but what happened? Now the sensor also scanning the line with across the track. Okay, so this is across the track. So across the track scan the earth series of the lines oriented perpendicular to the direction of motion of the platform across the swath F. So here is the if is the swath, then the line is like this. Okay, then this, then this. Okay, so suppose you can see here at first, if this is the A and this is the B, one thing, today I have not using my the digital slide because there is a power option problem in my laptop. So I am trying to class from different laptop, that's why the function ACOM not supported. Okay, that's why I cannot using the pen tab. And another option, today I am using the Google slide. Okay, because my friend's laptop have two Windows Microsoft PowerPoint 2007 only 7. Okay, that's why they cannot support it the editor pen. Okay, so I am using Google slides. So that's why you try to understand my concern, and you need to more concern about the topic. Okay, so across tracks corner, across means whenever the track is across. Okay, earth series of the lines are oriented perpendicular to the direction of the motion, where direction motion is the F. Okay, and directly perpendicular. So the sensor that is across the swath, example Landsat series satellite or Landsat series satellite as a example of Higgs broom. Another is along track or push broom. Higgs broom means, and push broom, suppose this is your track line. Okay, this is your track line A to B, but scanning is like a across along. Okay, so along track scanner use the forward motion of the platform to record successive scan lines and build up a two-dimensional image perpendicular to the flight direction. Here perpendicular to the flight direction, and the lines are oriented perpendicular to the direction of motion. In the across track is the direction of the motion perpendicular, but along track the dimensional image perpendicular to the flight direction. They use line array of detectors, where detectors is here. Okay, located at the focal plane of the image. Suppose here is the image, it is the focal plane formed by the lens system. B is the lens system, C which are pushed along the flight track direction C. Okay, and flight track direction along the track. So example spot IRS satellite. So IRS means the Indian Resources Satellite. Okay, clear everyone? Those are present in the classes. Clear? Across track and along track. Clear? श्रावणी, मदन, शुभजीत, साक्षी, लोपामुद्रा, अंकित, सुदेशना, इन सारे लोग को छोड़ के those are sitting in the classes. Clear? How, why? The answer is Higgs broom or spotlight sensor, also known as across track scanner. Example of Landsat series satellite. And along track scanner is the push broom. Push along tracks, push across Higgs. Okay, remember, I think in 2023 one question must be come from the sensor. Okay, they can ask about the sensor system of the scanning system. So along track is push broom, along track push broom, across tracks Higgs broom. Okay, thank you Ankit, thank you Sudeshna. Okay, thank you Lopamudra. So now go to the next question. Among the following which describe Stefan-Boltzmann formula? Among the following which describe Stefan-Boltzmann formula? Among the following which describe Stefan-Boltzmann formula? Option A, option B, option C और option D. Okay. So बिग बॉस आपको पूछ रहा है सवाल, क्या आपका सही सवाल क्या है? ऑप्शन ए, ऑप्शन बी, ऑप्शन सी और ऑप्शन डी. try to answer everyone. Please try to answer. Okay. Last 9 seconds. Okay. So option is here D. So option is D. M equal to sigma T4. Okay, not sigma divided by T4. Why Savani, Shubhajit, Mankit and Alexa? Answer A. Why guys, Shravani, Shubhajit, Ankit, Alexa and Sakshi answering A. Only Madan have right the answer. Okay, M equal to sigma T4. Okay, oh, Sakshi also. Sakshi also given, sorry, Sakshi also given that. Okay, so all bodies radiant energy W or watt equal to the energy depending on the temperature. So all bodies radiant energy W or watt depending on the temperature. Okay, T. So here W is the radiant energy, watt, and depending on the temperature T. According to the Stefan-Boltzmann law, W or watt equal to emissivity. Here the sign is emissivity sigma T4, where emissivity is equal to 1 for the black bodies and less than for the grey bodies, less than 1 for the grey bodies. Do you know the black body and grey bodies? Okay, okay. Do you know guys what is the black body and what is the grey body? So a black body is a hypothetical body. The black body absorb all the energy. Okay, a black body absorb all the energy in the all wavelength. Okay, and emitted all the energy in all wavelength. So black body is a hypothetical body that absorb all the energy, okay, at all wavelength and emitted or reflected all the energy in all wavelength. And grey body, what happened for grey body? Do you know the grey body is emitted more or transmitted more energy? Anyone? Black body emitted more energy or transmitted more energy? Shravani, Ankit, Pratanu, Sakshi, can you answer? The grey bodies transmitted all energy or emitted all energy? Sorry, the grey body emitted more energy or transmitted more energy? So grey body, all about know that the whenever electromagnetic radiation, okay, emitted, now whenever electromagnetic radiation or EMR, okay, interact with the surface. Suppose this is my upper palm, so this is the surface. When electromagnetic radiation interact with the object, some of the energy reflected or emitted, some of the energy transmitted and some of the energy absorbed. Okay, so in the black body all the energy is absorbed, again all the energy is emitted or reflected in all wavelength. In grey body, yes, intensity is different. Intensity means the energy. Okay, agree with this your topic, shorter wavelength and greater intensity. Yes, later I will be discuss. Okay, so now grey body absorbed more energy and transmitted more energy, that's why the emitted or reflected energy is less. So had less than is 1. So sigma being the Stefan constant. Okay, so here as the Sakshi have told, so here is the energy density joule per meter, okay, and wavelength nanometer. So what happened? Now in the Stefan-Boltzmann law, when the wavelength is shorter, okay, in shorter wavelength is the intensity of the light is higher, okay. So intensity of the light of higher is the energy is high. If the frequency is high, the intensity is high, then energy is high, okay. Whenever we go to the longer wavelength, that's why the energy is less, the intensity is less, okay. So suppose now question is why in the satellite sensor, okay, whenever we have using the optical wavelength, the spatial resolution in 10 meter sentinel image, why 20 meter in shortwave infrared? Anyone? In sentinel to satellite image, optical satellite image, in the optical sensor like a blue, green and infrared, band 8 have 10 meter spatial resolution, and why band 5, band 7, band 6, band 8A, band 10 and band 11, 12 also have 20 meter? Anyone? Those are certain. Okay, Lopamudra, okay, just give me acha, okay, no problem, no problem. So suppose so whenever pixel whenever we going to the shorter wavelength like the blue, green, red or gamma X-ray, the intensity of the light higher, okay, and frequency high, that's why the energy is high, okay. So that's why the area is smaller. So whenever go to the infrared, far infrared, okay, the intensity of light is less, that's why we have taking 20 meter spatial resolution, because we have covering the more area of pixel, the intensity of light is increases. That's why in the sentinel-2 image, blue band, green band, red band and infrared 8 band like the shorter wavelength have 10 meter spatial resolution, and band 5, band 6, band 7, band 8A, band 10, band 11 have a 20 meter resolution, okay. So black body is a hypothetical body or imagination of a body, okay, because in the real earth there is no black body. So in the what happen, if the energy is 100%, the black body is at first absorb all the energy 100%. After absorb the energy, the black body emitted or reflected 100% energy through the all wavelength like a blue, green, red, infrared, thermal infrared, radio wave, microwave, okay. And in the gray body, so what happened in gray body? The gray body absorbed and transmitted more. A example of gray body is glasses, okay. If you passing a light through your glass, any glass, okay, what happened? The more of the energy is transmitted and absorbed, okay, and reflected or emitted energy is less. So that's why called the gray body. Now Lopamudra and Sakshi, clear? Yes, to capture Pratanu, yes, to capture more energy, the spatial resolution is higher in the shortwave infrared, okay. Yes. So now go to the next question. The purpose of georeferencing is to sorry. Thank you Lopamudra, sorry. Patanu, Ankit, Shubhajit, Shravani, Please try to answer everyone. Madan. Okay. Shubhajit, why? The assigning spatial information, not spatial, is spatial. It is the spatial. So this is the little trick. Okay, this is not a spatial. What is the spelling of spatial, Abhijit? Shubhajit, what is the spelling of spatial? So the purpose of georeferencing is to converting data to a feature class, not assigning spatial information. There is just some spelling trick. Spatial, S-P-A-T-I-A-L. This is true, but here spelling is spatial. Projecting your data so that it has no restriction. No. After georeferencing have data distortion, because this is the resampling technique, nearest neighborhood, polynomial 1, polynomial 2, polynomial 3 order. So last option is D, assigning geographic location information, because the georeferencing means reference system to the geolocated. Geo means geographic location. Geographic location means the real location. Real location means the latitude, longitude. Okay, so latitude, longitude can be 3 format. Okay, one is degree decimal, decimal degree, another is degree minute second. If you convert the data in the 2D form, like a UTM, marketer projection, universal transfer marketer projection, then go to the meter. Okay, so clear everyone? If clear, press the yes button. The purpose of georeferencing is to, I think total 13 students present in the classes, only few students have participated. Okay, why? If clear, press the yes button to everyone. Okay. Okay, Ankit, Pratanu. Okay, I think my dear students have feel cold. That's why they wanted to. They don't wanted to know the type. Okay, they don't wanted to type. Now go to the next question. A very interesting question. Determine the energy of the wavelength if the reflected, absorbed and transmitted energy were given as 46 joule, 24 joule and 16 joule respectively. Thank you, Madan. Determine the energy of the wavelength if reflected, absorbed, transmitted energy are given as 46 joule, 24 joule and 16 joule respectively. Try to answer everyone. Okay, at first Patanu try to answer. Okay, Alexa. Okay, Madan. Okay, Shravani. Shubhajit, Lopamudra, Ankit, try to answer. Those are sitting in the classes, please try to answer. Okay, because it is the practice session. Okay, you have given the wrong answer, does not matter, because you are learning. Okay, not is your final set. So the answer is D, none of these. Okay, I have already discussed that total energy equal to reflected, absorbed plus transmitted energy. Okay, where given is 46, 24 plus 16, that means 6 plus 4 plus 6, 46 plus 24 and 16, how much? Yes, Alexa, is 86. Okay, if the option is 86 joule, that is right. So now go to the explanation. The energy of the wavelength can be expressed by using the energy balance equation, which is given as E lambda. E lambda means the energy equal to E r lambda, E am lambda and E t lambda on substitution. So where total energy is 100% equal to R means reflected energy, absorbed energy and transmitted energy. E r lambda equal to the reflected energy, A lambda equal to absorbed energy and T lambda equal to transmitted energy. So the answer is 46 plus 24 plus 16 equal to 86 joule. The total energy is 86 joule. So practical definition of emissivity. So for a unit of volume in a free space, a block of material that is not being acted upon by anything under isothermal steady state condition, that means that is a uniform temperature. The temperature is not changing over time. So 100% of infrared energy directed towards the unit of volume is either reflected, transmitted through or absorbed. So reflected plus transmitted plus absorbed sum 100%. If the object assumed to be opaque, then the amount of transmitted through the object is 0. Example of opaque body, anyone? If the object assumed to be opaque, can you tell me anyone about the any object like a opaque? Those are sitting in the classes, my dear students. Please write down a example of opaque body. I have the Shambhunath sir already discussed in the paid batch. Okay, what is the example of opaque body? Alexa, why? Can you elaborate the detailed message or detailed text? So try to remember opaque body in. Yes, wood. Yes, wood. Wood is the opaque body. Yes. So what happened? We have those are in the reading the physics or physical science. Okay. So every object have a normal temperature. Okay, what happened in the winter? We have feel cold. Okay, that's why we appearing muffler, topi, coat, and in the summer season we have tried to cotton, light cotton wear. Okay, so this is the same thing in the object. So whenever the object have a normal temperature, suppose this is the iron. Okay, the iron have laying down in a earth surface. Okay, this is the normal temperature. So what happened? The normal temperature, the molecules, the proton, electron are sthir. Sthir means the neutral. Okay, they have no motion. Whenever you hitting the iron rod, the energy is high. The protons, molecules, okay, have motion. So after motion the energy is transmitted. Okay, so for unit of volume free space, a block of material that is not being upon by anything. Okay, under the isothermal steady. So that condition called the isothermal, whenever the energy have no motion. Okay, whenever have the energy have no motion, that's called the isothermal steady state condition. This means this is a uniform temperature. The temperature it not changes over time. Okay, so whenever you changes the temperature of iron rod, you have going to the red light, because we know the infrared is the or red is the higher longer wavelength. Okay, so that's why the energy is transmitted and it is going to the rate. Okay. So what happened? Now 100% energy equal to transmitted energy, reflected energy and absorbed energy. Clear everyone? Those are sitting in the classes. Anything through which light can travel. Is the example of iron rod. If I passes through the iron, the light can be travel. Clear everyone? Okay, thank you Shravani. Okay, thank you. So Shravani, Alexa, Madan, Ankit. Okay. Now go to the next question. Okay. The interaction of the electromagnetic radiation produced with a specific wavelength to illuminate a target on the terrain of further study, its scattered radiance is called. Okay, thank you Ankit. Thank you Shravani for your confirmation. So answer is A. Okay. The interaction of the electromagnetic radiation produced with a specific wavelength to illuminate a target on the terrain for the starting scatter radiance is called the passive remote sensing, not encrypted information. Why? WhatsApp using encrypted information. Can you encrypt the satellite digital signal? Okay, in the 264 bit. So the what happened? The interaction of the electromagnetic radiation produced with a specific wavelength to illuminate a target on terrain for starting scatter radiance. Okay, it's called passive remote sensing. Okay, those are active remote sensing. They have tried to answer active or passive, but those are encrypted. Why encrypted information? Do you know what is the encrypted information? WhatsApp, Facebook Messenger, they have using the encrypted information. Encrypted means the data convert. Suppose you have studied hello sir. Okay, so the message is converted. Now WhatsApp using 264 encrypted or 254. Okay, that means the data converted in 254 bited. Okay, for the cyber security, that called the encrypted information. What is the passive remote sensing? Anyone, what is the passive remote sensing? Now in the passive remote sensing, the energy have own source or different source. Now in passive remote sensing, the energy source from the different object. Okay, in the sun is the main source of energy. Okay, so what happened? Now the electromagnetic radiation produced with a specific wavelength. So sun have a energy from what? Cosmic ray, X ray, gamma ray, ultraviolet ray, then visible, infrared, microwave, radio wave. Okay. Okay, so what happened? Now the interaction of the electromagnetic radiation produced with a specific wavelength to illuminate a target, on the train for the starting is scatter radiance. Okay, scatter is called the reflected. Scatter radiance means the reflected energy is called the passive remote sensing. It is very easy. Okay, guys, you hopeless me. Now go to the next question. Which of the following indicate the correct set of in passive remote sensing satellite use EMR energy? Not. In passive remote sensing the sensor recorded energy from a different object or source that have illuminated. Okay, if the energy have own from the sensor, okay, or satellite, and the energy hitting the object and the sensor measuring that illuminated energy, that called the active remote sensing. Okay. Try to answer everyone. Only Madan, Subhojit, Pratanu, Sudeshna, Alexa, Ankit and Shravani have answer. B option is shorter wavelength, high frequency. Okay, which of the following indicate the correct set of combination of gamma waves? So in the electromagnetic spectrum where gamma wave is situated, here is the gamma wave. Okay, so here is the high frequency or a less frequency. Those are answer A, B. Okay, Subhojit and Pratanu, tell me, in gamma wave have high frequency or less frequency? Pratanu and Subhojit, tell me. Tell me, Subhojit and Pratanu, the gamma wave have high frequency or less frequency? Madan, tell me. Gamma wave have high frequency. So if the frequency is high, the wavelength is less, because all about know that the wavelength and frequency are inversely proportional to each other. If the frequency is high, then wavelength is less. If frequency is less, the wavelength is high. Okay. So now go to the which of the following indicates the correct set combination of gamma waves. Here saying about the gamma waves, guys, gamma waves only. So here is the shorter wavelength have high frequency. It is true, longer wavelength less frequency, but here mention gamma waves, guys. Please read carefully before answer the question. Okay, otherwise you have take a bamboo. Okay, in the GATE exam in negative mark. If the question is 2 mark, you have to 2/3, and question is 1 mark, 1/3, take a bamboo. So which of the following indicate the correct set of combination of gamma waves? Shorter wavelength is high frequency, that is the appropriate answer. Longer wavelength less frequency, if I am talking about the radio wave, microwave, that is the true. Shorter wavelength less frequency, not. Shorter wavelength is high frequency, longer wavelength less frequency. Okay, now clear, Subhojit and Pratanu? Why answer is B? Now clear. I want to confirmation from Subhojit and Pratanu. Okay. Subhojit, clear? Why answer is B? Okay, thank you. So Shubhajit, be careful. Okay, at first read the question. Be carefully. Be carefully. Be careful. Okay. So the electromagnetic spectrum ranges from the shorter wavelength, including gamma ray, X-ray, to the longer wavelength, microwave and broadcast radio waves. So gamma ray, X-ray, ultraviolet ray, visible, reflected, thermal, infrared, microwave and radio wave. So here is frequency is high and wavelength is longer. Here frequency is less and wavelength is high. Okay. Now go to the next question. The lens used in aerial photogrammetry is having a maximum coverage capacity of Alexa, you can go through the previous year lecture. There is a playlist remote sensing GIS tutorial. I have covered some GIS topic. Okay, and if you want to the buy the paid batch, okay, all the study material, structure, notes already available in paid batch. This is the last time offer. You can payment 2000 at a time and you can access all the study material and notes. Or Alexa, you can go for the GIS. One is most famous book Kang Sang Chang. Okay, a introduction to GIS by the Chinese writer Kang Sang Chang. Okay, you can cover the GIS portion from Kang Sang Chang. A introduction to the GIS book name, a introduction to the geographical information system by Kang Sang Chang. So the lens used in aerial photogrammetry is having a maximum coverage capacity. The answer is 93 degree. Okay, why? Suppose this is my hand. Okay, again. So this is angle of 30 degree. So how much cover? This portion only. If I have removed it, okay, this is 45. That portion only cover. Okay. Now go to 60. That portion over cover. Now go to the 93. How much cover? More cover. Okay. Clear everyone? Why answer is 93? Lopamudra, Sudeshna, Ankit, Shravani, Sakshi, Shubhajit, those are sitting in the classes. Clear? Okay, thank you everyone. Now go to the next question. Which of the following is not classification of the scattering principle? Which of the following is not a classification of scattering principle? Option A, non-selective scattering. Option B, relay scattering. Option C, mixed scattering. Option C, Faraday scattering. At first, Shravani, then Sudeshna, Shubhajit, Pratanu, Madan. Ankit, Lopamudra. I think my paid based students is more active and they have answered the more. Okay, those are in the different kind of background. You have not any paid badge or any proper guidance. Don't worry. Through the MCQ series, you can qualify the GATE. Okay, because in the previous year, my few students have a good rank in the through the MCQ series. Okay, so guys, you need to the proper concentration, proper understanding about the class. Okay, so which of the following is not a classification of scattering principle? The answer is Faraday's scattering, because we have know about the Mie scattering, relay scattering and non-selective scattering. So what is non-selective scattering? Anyone? The major characteristic of the non-selective scattering. When selective scattering is occur. Anyone? Subhajit, when non-selective scattering is occur? Shravani, Lopamudra, Ankit. Alexa, Faraday is not a scattering. Which of the following is not a classification scattering principle? Faraday is the nothing. Here question is which of the following is not a classification scattering principle? There is three type of scattering: non-selective, Mie and relay scattering. Okay, at first try to understand the relay scattering. When the particle materials okay are shorter than the wavelength, okay, that time the relay scattering occurring. That's why our sky is visible like a blue, because blue light is scatter more, okay, due to the, because in the upper atmosphere there is a no thickness particle materials, okay, but whenever going to our ground, our the near about the atmosphere, okay, there is a dust, there is a different kind of particles, there is a different kind of molecules, PM 2.5, PM 10, okay, particle materials. That's why the Mie scattering occurred, because when the wavelength is shorter than the particle materials, that time the higher wavelength is scattered. That's why at the sunset time we have seen as a orange or red color, okay, like a pink orange, okay, और रेड ऑरेंज. हाँ, हम इसलिए सनसेट का समय आकाश में क्या देखते हैं? लाल कलर देखते हैं, इसलिए ड्यू टू द occurring of Mie scattering. A non-selective scattering, now when the scattering occur all direction in all wavelength, so non-selective scattering condition cloud fog, okay. Yes, Sakshi, yes, fog and clouds appear white in non-selective scattering because the all energy is scattered in all direction in the through the all wavelength. Yes, Ravani, yes, particle size is longer and wavelength is small in Mie scattering. Yes, size greater than 10 to the power wavelength. So the plane of survey plotted up a scale 10 meter to the 1 centimeter, that is reduced such as y that a line original 10 centimeter along now measure 9 centimeter. The area as the reduced plane is measure 80 square centimeter, okay, 81 square centimeter. The actual area of meter survey is okay. Can you more than explanation? Why option A? The plane of survey plotted to a scale 10 meter to 1 centimeter reduced in such way that a line originally 10 centimeter long now measure 9 centimeter. The area as the reduced plane is measure 81 centimeter square. The actual area of the survey is. Shravani, can you explanation why option A? The answer is A. The plane of survey is plotted at scale 10 meter to 1 centimeter square. 1 centimeter. 10 meter to 1 centimeter because in the ground 10 meter represented on the map 1 centimeter. Okay. Suppose Madan prepare a map. Okay. The actual size is 1 centimeter 10 meter. But what happened? Madan want to micro. Okay. Madan need to microcopy to take a copy notes in the exam center. Okay, do you see in the micro? So what happened in micro? Now to reduce the actual size to the shorter size. Okay, so what happened? The actual size is 10 meter. Okay, so the area is, if today I am not using pen tape, skip the question. The answer is 10,000. Okay, another day whenever my laptop is oiling, I will be discuss in broadly how to measure. Okay, there is a technique, reduce of map. Okay, now go to the another question. Put the visible light colors in order from longest wavelength to the shorter wavelength. Put the visible light's color in order from longest wavelength to the shorter wavelength. Option A, option B, option C और option D. आपका आंसर लग करिए. Option A. Yes, success. Shrink length by the actual length. Yes. Okay, at first or more than the answer. Put the visible light's color in order from longest wavelength to the shorter wavelength. Okay. So I seen here is answer is different kind of answer. A, option B, option D. So here question is, put the visible light colors in order from longest wavelength to the shorter wavelength. যারা বাংলায় আছো ঠিক আছে, বেনিয়া সহকলা পড়েছো, বেনিয়া সহকলা, or those are have a English medium, Vigora. Okay, the short form is Vigora, and in the Bengali medium have students the Beniya Sahokola. So put the visible light colors in order to longest wavelength to the shorter wavelength. The option is red, orange, yellow, green, blue, indigo and violet. Okay, so at first here why not be red, yellow then green? Yes, but red के बाद क्या आता है? Orange. Okay, this is the proper combination of the longest wavelength to the shorter wavelength. Is the combination of shorter wavelength to longest. At first violet, then indigo, then blue, green, yellow, orange and red. Remember it. So whenever we have passes a light through the medium of water. You can see the seventh color. Okay, हम बचपन का टाइम में क्या होता है, एक छोटा मिरर का टुकड़ा, हमारा जो मिरर का टुकड़ा किसी एक पानी का पॉट में रख के हम सनलाइट का बेसिस में देखते थे कलर. ओके, उसमें क्या होता था, उसमें टोटल 7 कलर था. ठीक है. सो द इन द लॉन्गेस्ट वेवलेंथ इज रेड, आफ्टर दैट ऑरेंज, येलो, ग्रीन, ब्लू, indigo and violet. Okay, so now go to the next question. So here is the some description. Violet shorter wavelength around 400 to 420 nanometers with high frequency than indigo 400 to 440, blue 440 to 490, green 409 to 570. You have take a screenshot. Please take a screenshot. Okay, whenever you completed the screenshot, after that I go to the next question. Okay, whenever you completed the screenshot, then I go to the next question. Okay, okay, Alexa, don't worry about it. Today I am taking a live class from a different laptop. Okay, that's why there is a some technical issue. Okay, and some band ratio issue, that's why it is the slow mode. And don't worry about it. From the previous classes I have tried to as a live mode. Okay, don't worry. So clear everyone, you have take the screenshot. Now go to the last question. For a light ray having a wavelength equal to 200 nanometer, calculate the frequency. Sakshi, can you explain the answer? How to get option A? Can you explain the Madan in chat box? Okay, Ankit. Okay, so the answer is 1.5 into 10 to the power 4 hertz. Okay, so all about know that C summon lambda mu. Okay, so where C is the speed of light equal to lambda u. So EQ through the equation C equal to lambda mu. Okay, so please yes, frequency summon speed of the light by wavelength. Okay, so here speed of the light is 3 into 10 to the power 3 into 10 to the power 8 meter per second divided by Please follow your chat box, okay, because I have no using the pen tape today. By 200 nanometer, here nanometer is the wavelength. So whenever you multiply, so at first meter per second to convert it as a nanometer, after that you get the answer. The answer is 1.5 into 10 to the power 14 hertz. Okay. And if you have not clear, whenever I conduct the MCQ series, I will cover the two question, okay, two math question in this series. One is for the wavelength, another for the shrink size, map shrink size. Okay, so all about the today classes. Thank you everyone. If you have any query, any question about the classes, you can now ask me. Okay. So if you have any kind of query, question, now you can ask me. Okay, Sudeshna, thank you. Thank you, Shravani. Thank you, everyone. Thank you, everyone. So again, if you have any kind of problem, any kind of query regarding the geomatics engineering, you can ask me. So before leave the class, please hit the like button. It is my humble requested, okay, because no one channel cannot detail explain, okay, they have only go through the question and answer, okay. It is my humble request, please try to share it among your friends, among your junior, among your senior the channel, okay, because I have left 800 watch hours from achieve my milestone, okay. I have started my journey during the COVID 13 June 2020. Now it is 16 December 2022, but my channel is not monetization or not, because due to the less watch time, okay, because I cannot get the time to conduct more classes because I have busy in my job, in my research, in my paid batch, okay. So if you guys support me, I will conduct more classes on YouTube, okay, for better understanding, to boost your concept, to evaluate your study, okay. So thank you again, once again thank you to attend the MCQ series. Bye bye, tata, good night. Good night, okay. Thank you everyone, thank you, tata, thank you, tata. Okay, good night Madan, good night to everyone, good night, good night, good night.